Hello everyone, welcome back. Today we talk about thin provisioning. Thin provisioning gives us the chance to create an immensely large file without immediately using all the capacity or all the storage. Thin provisioning is a storage concept typically associated with disks. When we look at files, there is a concept called sparse files, and sparse files are kind of the same idea. You basically create a large file, you give it a capacity of, like a terabyte, and while you keep adding data to this file, it keeps increasing in size. A typical use case, for example, is virtual machines or virtual machine disk images. You create a disk which is 20 gigabytes in size or can grow up to 20 gigabytes, and then VMware or whatever asks you, like, do you want to have this like thinly provisioned or thick provisioned, basically provisioning the whole file up front, saying, hey, this is 20 gigabytes, so it will assume 20 gigabytes from the storage internally. So now assume we want to implement a thinly provisioned storage. To do that, we first need to understand what it normally would look like when we have like three virtual machines of three independent disks, right? So we have a disk here, and we have a disk over here. And finally, we have a disk over here. So that is VM1, VM2, VM3. So three virtual machines, three independent hard disks. The first one is used roughly 50%. The second one is very, very barely used. And the third one is almost full, right? Just to make sure, this is our capacity. Basically, how much I can store in this disk. And this is the current usage, whatever it is, right? So assume that is like 20 gigs. And we have used something like 18. I don't know, something like that. So let's assume we want to implement a storage technology based on thin provisioning. First of all, we need to understand how that actually works. So we have VM1, we have VM2, and we have VM3. Those are like virtual machines, and every single virtual machine has a storage, normal storage disk attached, nothing fancy. Imagine it your hard disk. We have about 50% used, about, 10%, and about 90% used. That is the capacity, and that would be our storage usage, whatever it is. Usage. What we see is that in virtual machine 3, we're almost running out of disk space, while as in virtual machine 2, we have plenty of disk space left. So how can we solve that? And that is where thin provisioning comes in. So instead of making disks or virtual disks of that size, we can actually make virtual disks of that size, right? So if you imagine that would be 20 gigabytes, that could be like a terabyte. Let's go big here. Every single disk we do has 1 terabyte of storage capacity, right? Not disk usage, but disk capacity. That means we're still just using something, right? We're still very, very, very narrowed down, and that is about here. But we still see that we also see that we have plenty of capacity left. Because in the underlying storage, and that is where thin provisioning comes in, if we now assume that we have storage that is thinly provisioned, the underlying actual backend storage kind of looks like that. So we have, let's use different colors real quick. So let's make this that color. So we have this one here. We have blue over here. About that maybe. And we have green, green over here. So green is about that. Right? What we see is, because the way data is stored in a thinly provisioned system, it doesn't matter how large our virtual disks are. We're basically just doing whatever, or we're just using whatever we need. That means that with thin provisioning, you get much more out of your underlying storage, and you always only need or use what you need. From a customer perspective, if you build a hosting system, you could give your customers an infinitely big storage capacity and literally have them pay by the exact usage they have. I hope that was interesting. I hope you see where Fin provisioning really shines and how it helps you save money, but also bring new features to your customers or to your other departments or whatever you think of being your customer in that sense. And I hope you come back next time.